Hello and welcome to my SplashKit Sprite walkthrough. I'm going to be showing you today how you can use sprites to make elements that you can associate with bitmaps or animations if you have them, add some layers, make them do things, make them interact with each other, and hopefully you'll be able to find today's walkthrough useful. Okay, now the first thing I'm going to do is just create a game class, which is just going to be somewhere for us to handle our elements, our sprites, and put them in just to organize them. It's going to need a window, which is just the window we're going to be drawing our sprites to. So I'm just going to call that sprite window. We're going to need a couple of bitmaps for our sprite. I'm actually making a mouse sprite, so we're going to have a mouse front, and there's also going to be another bitmap for the mouse back, which I'm going to assign a little bit later on. And it would be excellent if I could spell private. Let me just fix that. Alright, and of course we have our sprite itself, which I'm actually going to call mouse S for sprite. And those variables will get us started. So I'm just going to go in quickly and make our game constructor. It's going to take our window that's going to tell us the window that we're going to be drawing these to. I'll just set our sprite window variable to be that window that's passed into the function. I will set up a bitmap for our mouse back, and if we go and have a look in my resource folder, here's one I prepared earlier. So there's the image that we're using for the mouse back for our sprite. Alright, so I'll just be calling that back of mouse, and I will pop in that name of that file to set that up. And to make a sprite, all you actually have to do at a minimum is assign it a bitmap. So we actually have enough to go ahead and create our sprite. So I'm going to assign our mouse S sprite as equaling a, now we can use our SplashKit.create sprite method. It's actually overloaded. So if we pop over and have a look at the SplashKit site for a moment and have a look at that create sprite method, you can see there's a few different options there. As I was saying there, you can just give it a bitmap. That's all it actually needs. You can give it an animation as well. I don't have an animation, so we're not going to be doing that. I'm actually just going to take the option of a name and a bitmap. So if we go in and look at the C# option, that tells us the structure of that function. So I'm just going to call it mouse, and I'm going to give it that bitmap we created for the mouse back as a bitmap layer. And now we have a sprite. Alright, now I'm going to tell it to move somewhere because we actually want it to turn up. So by default it'll come up in the top left corner of our window, but I actually want it in the middle of the bottom. So I'm actually just going to get, for our x value, just ask it to get the width of the window divided by 2, and we're just going to take half the width of our sprite. There's another handy property there we can use straight up, just using that sprite name.width, and take half of that just because I want the middle of the sprite centered, and then I want it in the bottom. So we're just grabbing the height of the window, and we're going to similarly get the property for the height of that mouse sprite, just using the dot height, and take that away just because I want its feet at the bottom of the window, not its head with the rest of that sprite disappearing off the screen. So that's all that's doing, just giving us the position of that sprite being the center of the bottom of that window. Okay, I'm also just going to have a function to organize some of the drawing and the listening to the keyboard for events. So I'm just going to call that update. And in there, I'm going to call SplashKit's process events so that it's listening for input to the keyboard, because I'm going to use that in a moment or two. And I'm going to have it clear the window, just using the color white. and I'm going to get it to draw our sprite, which we can simply do with SplashKit.draw sprite, which just takes the actual name of our sprite. So that's pretty easy. And then, of course, we have to remember to refresh that window, otherwise we won't actually be able to see our sprite, even though it's drawn. So back in our main method, we want to create our game, so we'll need a window for that. So I'll have a new window, I'll just call it My Window. Title it Fun with Sprites. Are we having fun? And I'm going to make a new game, passing it that window. And then just while nobody closes that window, so while my window not closed requested, or not my window closed requested, I'm just going to call the update function on that game. Alright, so that should have created a sprite, placed it in the bottom center of the screen using those calculations, we hope. And we'll just see what that does. So that's great, we've got our mouse in the center bottom of the window where we want it. It's not very exciting though, it's not doing anything. Also, you can see there's an error message there telling us we never used our front of mouse bitmap, which we didn't, but we're going to use it now because I want to take some input from the user, depending on the arrow keys, move our mouse, and if it's going up away from us, the back of the mouse is fine, but if it's coming down the screen towards us, I want to see the front of the mouse. So there's a nice way that we can do that with sprites using layers. So the bitmap that we originally gave the sprite will be on its layer 0, but I can actually add more layers and then utilize them. So if we go back into my game class, we need to set up another bitmap for the mouse front. So I'm just going to do a bit of copying and pasting to save typing there. And what I'm going to do is make our mouse front bitmap now belong to, I'll call it front of mouse. And we're going to be using mouse pick 2, which if we have a look, there we go, there's a little front of the mouse pick for us. And then I can add a layer by just using my sprite name and then .add layer. And I just need to give that a bitmap. And then I have to give it a string just to name that layer. I'm just going to call that front. Now I'm going to make a handle inputs function, which is going to be used to move the mouse and change the layer depending on what arrow keys are pressed. So I'm going to actually give it just a constant integer first, just to set the speed, which just relates to how fast it'll move. I'm going to set that to 8. I'm also going to need a couple of doubles for the X and Y position of our mouse sprite, which I'm going to keep track of and then move. So double MX, and I can get the X value of the mouse sprite directly with SplashKit.SpriteX and just give it my sprite name, and that'll pull it out for me. And I'll do the same with my MY to get the Y coordinate of our mouse sprite. And so these we're going to adjust utilizing the speed depending on the key that's pressed. So we'll have some if statements here, and we'll just use SplashKit.keyDown function, and we want this to happen if the key that's down is the up key. So if that's the case, we're just going to take MY and we're going to reduce it by our speed, remembering that the Y coordinate goes from top to bottom. That's effectively going to make our Y coordinate go up. And of course we want the opposite if the down key is pressed down. All right, and so we're going to need to add speed to make it actually appear to move down our screen or down our window. Now also, if it's moving down, it's coming towards us. So this is where I want to see the front of the mouse or the front layer of the mouse. So I'm going to hide with sprite hide layer, and then I give it my sprite name and the number of the layer we're going to hide, which will be 0 because the first layer that we assign is the 0 layer, like indexes in an array or list. And then we're going to have sprite show layer, to show layer 1, which is the next layer I added, which is actually that front pick of the mouse. And if we've got the mouse going up now, of course we're going to have to reverse that. So I'm going to have to go back into my if statement for the up key and reverse that process. So I'll just copy and paste that again to save some typing. And I'll just reverse those numbers. So if we're going up, we will hide the front and show the back. Okay, and now I'm just quickly going to add a couple of if statements so that we can have our mouse going left and right. I'm happy for their picture to remain at whatever it was before. So if it was coming towards us, it can move to the side with the front, and similarly for the back. So we'll just set them accordingly and modify our x coordinates. And of course, once we've done that, we will need to handle input to take that in. Oh, and we'll have to set the x and y, otherwise we haven't actually moved it. We've just calculated a new x and y for it to go to, but we never actually told it to go there. So we'll just use the SplashKit.move sprite 2 again, and we put in our sprite name and then the mx and my that's now been adjusted. And we'll see how that goes. So you see he'll turn if we come down, and similarly to go back up. It's a bit boring though, he doesn't really have anything to do. To amp up the excitement, I'm actually going to add some more sprites. I'm going to add some cheese for our mouse, multiple cheese in fact. What I'm going to have to do here is make a new bitmap for the cheese. So I'm going to make a bitmap that I'm just going to call cheese pick. And I'm actually going to make a list of sprites because I want there to be lots of cheese. Veritable cheese board. So I'll have a private list of sprites which we'll call cheese. Oh, and this is telling me, flagging for me that I haven't actually included the correct usings to be able to use list. I have to have my using system dot collections dot generic, and now it should recognize what list actually is. And there we go. Okay, now in my game class, I'll have to make my cheese a new list of sprites. And I can make my cheese pick bitmap, a new bitmap. I'm going to call it cheese. I'm going to assign it to my cheese pick that I created earlier. Oh, and that's what it looks like. Now, where to make the cheese and how to make the cheese. I'm actually going to make a function for making my cheese because I want to call it more than once. So I'm just going to call that more cheese. And it's going to take a float x and a float y for coordinates for reasons that will become clear soon. And we're going to need, of course, a sprite for our cheese. I'm going to call it new cheese because we're going to keep adding it to our cheese list. And we're going to use our trusty SplashKit.createSprite function. This time I'm going to use the form that just takes a bitmap because I don't see the point in naming my cheese when I'm just adding numerous pieces. I don't care what they're called. Now I'm going to add this sprite I've just created to our cheese list. So cheese.add, and I put in the sprite item of new cheese, and I'll just add it to that list. I'm then just going to set its x coordinate using SplashKit.setSpriteX. Nice little function for that, which I just have to give it the name of our sprite and the x coordinate as we took in through the parameter. Do exactly the same thing with the y, with the sprite set y. And I'm just going to show you some things that we can do with the functions here. So I'm also going to use SplashKit.SpriteSetRotation, which sets the rotation. I'm just going to make that, I have to give that the sprite, otherwise it doesn't know who to rotate. And then I'm giving it X, just because it's just for demonstration purposes. I'm also just going to make a vector so that I can show you how to use some sprite vector cool stuff. So we'll have a vector 2D cheese vec, make that a new vector 2D, and I will just set the X and Y components of that vector to the float X and Y that we got in through the function parameters. Again, no good reason for that, just demonstrating. So we'll get that Y to equal Y, and we can actually set a sprite's velocity using that. So SplashKit.Sprite set velocity, we can simply tell it our sprite and that cheese vec that we just created and set the velocity easy as that. I'll add a float speed, which I'll use SplashKit's random function, and we'll times that by 10 to just give us a number between 0 and 10. And we can use another function, which is nice, a SplashKit dot sprites set speed, and then give it again our sprite and the speed that we just created. So as easy as that, we just set a whole heap of things using functions quite easily. Rotation, X, Y, velocity, speed. So I just wanted to sort of show you how easy that was to do. Now we need something just to call this more cheese. I'm going to make it when the user presses a space bar, we're going to make a new cheese. So back in handle input, I'm going to, I don't want it if it's a keys down because it'll just keep making too much cheese. So I'm going to use a key typed, SplashKit key typed, and then we want the key code to be space key. So if that's what it is, we want to run the more cheese function. I don't need those brackets because it's just a single line thing. So we'll call more cheese, X and Y. I'm just going to call it CX for cheese X and CY for cheese Y. It's getting upset because I haven't told it that those are things yet, but we'll go back and sort of do that backwards. All right, so back up here. Don't forget their floats. I just want it to be a random value across the width of the window for my X value. So I'm just going to use SplashKit.rand and times it by the sprite window .width to basically give me a random value across the width of this window. I'm going to do a similar thing for my cheese Y value, except this time, of course, I will use height. So it's just going to give me an X and Y randomly placed across the window that we can then be putting into that more cheese function. So when the space bar is hit, it's going to call that more cheese function, do all of those things with the X and Y value that we gave it. We can't forget though, now that we've done all those things with our sprite, that we actually haven't drawn it yet. So we need to go back to our update method. We don't actually have to draw them individually. There's a nice little draw all sprites method that we can use instead. We can even take out our mouse now. And now let's just see what that does. Let's go. There I am. Now if I press the space bar, oh look. So notice it's drawing our mouse and all of our cheese. Also notice though, there's not much velocity or rotation going on there. There's a reason for that. We actually need to call an update method, an actual sprite update method to make those special functions do their thing. So we need to go into our games update method and just put in SplashKit update all sprites. Try that again. And that should work a little bit better. Fingers crossed. See how we go. Yeah. Oh, there we go. That's a little bit more exciting. Still not much interaction between objects though. No interaction, in fact. Let's fix that. Let's do some things when these sprites collide. Okay, to organize this, I'm just going to make a new function called check for collisions. And in it, I'm going to actually make another list of sprites. I'm going to call it old cheese. And I'm actually going to use this to keep account of the cheese that I'm going to want to remove because the mouse has collided with it or eaten it, depending on your perspective. So I'll just make that a new list of sprites. And for each sprite in cheese, so this is just going to go through and check against each sprite in our list of cheese. Now this is great here. We can do a SplashKit.Sprite collision method, which we can call on two sprites. So we just call that on the sprite in our list and on our mouse sprite. And simple as that, it will tell us if there's been a collision between the two. Note that by default it's a bitmap collision, but you can actually change the type of collision if you want using SplashKit methods. You can check that out on the SplashKit website if you're interested in doing that. But this is perfect for me, so we'll leave it at that. All right, so if there's actually been a collision, we just want to add the sprite that we were checking against to our old cheese list. And then for each sprite in each sprite in old cheese, we want to remove it from our list of cheese. So it's cheese.remove a sprite. But also, the sprite still exists. If we ask it to draw all sprites and we just take it out of the list, it's still going to turn up. So we actually need to destroy it or free it, depending on whether you want to use a slightly nicer way of saying it. So we actually need to use SplashKit.freeSprite, and then we just give it sprite. So now it's actually destroying that sprite effectively, and none of the functions or update all sprite or draw all sprites will operate on that sprite anymore. It's gone. So now I want to make another list of sprites called reverse cheese. This is going to keep account of any cheese that I want to reverse the trajectory of, or the velocity, the vector of, because they've collided with each other. So I'm also going to need a vector 2D, which I'm just going to call IVEC, inverted vector. And it's going to be a new vector 2D. I'm just going to use that for when I reverse vectors. And then for each sprite in cheese again, I'm going to go through and I'm going to check it against its own list. So for each sprite 2 in cheese. So every item in the cheese list is going to compare itself against every other item in the cheese list. So we use our nice sprite collision method again to check if our sprite has collided with sprite 2. So this way every cheese in the list is checking against itself, or every other cheese in the list, or all of the cheeses in all of the lists should check if it's collided. And if it does, we need to check other things, because we don't want the sprite to be looking at itself again and counting that as a collision. Also, we don't want, if a cheese the first time through compares to another cheese and works out it's collided, when the reverse pairing happens the second time around, I'll fix that up, we don't want that to make it reverse itself twice and end up back where it started, if that makes sense. So we only want to count it the first time it checks, and we don't want to count it at all if it's just found itself. So if those things both aren't true, we will just add that sprite to the reverse cheese list. And then when we've gone through and found all our cheese to reverse, then we can do what's necessary to reverse them. So for each sprite in reverse cheese, we're going to set our inverse vector to, and we can just use the SplashKit vector invert function. And the vector we're going to invert is the vector of the sprite. So we can use our SplashKit sprite velocity, and that grabs the velocity vector of that sprite. And then we can simply use our sprite set velocity to set the velocity of that sprite back to that I vector we just created. And we're just also going to set the rotation just to show you how easy it is to grab the rotation, because I can just say sprite rotation in SplashKit with the sprite and then add 3, and I could just grab the existing rotation, add 3, and then it will set it to a new rotation, just to show you how easy that is to modify all of those things with very simple functions. So now we need to actually check for collisions back in our update procedure or process function. And if we run that, let's see what happens. Oh, there's a little slow collision down there. Oh, we have a mouse who can pick up some cheese. I'm just trying to keep it out of the way at the moment because we want to see if we can get more of that cheese colliding. There we go. It's a little bit more satisfying. So those are quite a few things that you can do with sprites. As I said, there's more. You can check out the website. You can add animations, but as you can see, very easy to grab information, set information, draw all your sprites, update all your sprites, handle them all. A lot of that hard, heavy lifting is done for you. Hope you've enjoyed my little walkthrough and you got some useful information out of it. Thanks, guys.